All right. 8 and 9 are very similar to each other, so I'll start you off with these two, or maybe I'll do 8 and then 9. I'll just start, well, let's start with 9 because it's actually much simpler. So this one is the integral of just ln x with respect to x. This is not a standard integral. You shouldn't just memorize it, although you may have. Uh, Oftentimes, a mistake that students make is saying 1 over x. 1 over x is the derivative of ln x, not the antiderivative. Antiderivative would be the thing that you integrate, or, well, antiderivative is the integral. So it's not a product, so we cannot do reverse chain rule. But ln x is one of those exceptional things that you just memorize that, hey, this is going to be a parts problem. So ln x classically is solved by integration of by parts. So because there's only one function, you let that guy be u. So we start by saying let u, and even it would win anyways because you would have laity. And if you don't see it as a product, maybe we need to rewrite this as the integral of ln of x times 1. Because any function can be written as itself times 1. So maybe we can do that if you see the product better that way. So we start by letting u equal to ln of x, and that means du dx is equal to 1 over x. The derivative of ln x is 1 over x, or that du is equal to 1 over x dx. Also, we let dv is going to be whatever's left over. So if ln x, if this guy is u, then this guy has to be dv. Or if you really want something in front of it, you can say 1 dx, but it's the same thing. So let dv equal to dx. And now if we integrate both sides, we're going to get v is equal to x. The integral of dv is v. The integral of dx is x. And now we can say by parts, integral of u dv is equal to u times v minus integral of v du. Well, u is ln of x, dv is dx, so that's the left-hand side, equals u is ln of x times v is x minus the antiderivative of v, which is x, times du, which is 1 over x dx. So far, so good. Well, x over x is just 1, or x times 1 over x is just 1. So this simplifies now to ln of x times x minus the antiderivative of 1 dx. Well, the integral of 1 is x plus the almighty constant. And that's it. The antiderivative of ln x the integral or the antiderivative of ln of x with respect to x is x times ln of x minus x, plus c. So when you just have single functions and there's no compositions, nothing that would lend itself to substitution, try to consider just using dv as dx. The other one I think was arc cosine of 2x. Yeah. With respect to x. So here the argument's the same. Even if we were to do u substitution, u could be 2x. The derivative of that is 2. So all we're really doing is even if we do substitute here, this is going to get converted into integral of arc cosine of u du over 2. I don't know if that's necessarily easier to solve. So that's why I said u substitution. Could it be done? Sure. But if you don't know how to integrate arc cosine of 2x, you probably don't know how to integrate arc cosine of u either. This is also, so just inverse trig functions by themselves, arcsine, arccosine, arctangent, they by themselves are also classic parts problems. Just like ln x is a classic parts problem, inverse trig functions being integrated just by themselves, no products, no quotients, by themselves, there are classic parts questions. So let's do what we did with the previous problem. Rewrite this as antiderivative of arccosine of 2x times 1 dx. You don't have to do that, but this is just me trying to show you that, hey, it is a product, which means parts becomes a reasonable choice. And again, we can say laity here off to the side. We have an inverse trig function, so that's going to be u. Didn't really have any other function, so that had to be u, even if we forgot about laity. So we say let u equal to arc cosine of 2x, then du dx is equal to -1 over square root of 1 plus 2x, the quantity squared, times the derivative of the argument, which is 2. This is why we need to know our derivatives. So it's -1 over the square root of 1 plus this argument squared times the derivative of the argument. So the derivative of 2x is 2. Or we can say du is equal to -2 over the square root of 1 plus 4x squared dx. I'm multiplying the dx over to the other side, and -1 times 2, I'm just multiplying together, just to reduce how much I have to write. So that's u. Also, let dv equal to what's left over, which is dx. That's the easy part. Then v, if we integrate both sides, would just give us x. Integral of dv is v, integral of dx is x. Okay, by parts, integral of u dv is equal to u times v minus the antiderivative of v du. This means u, which is arc cosine of 2x, times dv is just dx. I need a times there, equals u, arc cosine of 2x, v, which is x, minus antiderivative of v, which is x, times du. du is this big guy up here. -2 over square root of 1 plus 4x, the quantity squared, dx. So what parts has allowed us to do is say, I don't know how to solve this problem. Too hard, too difficult, whatever. I just don't know how to do it. So let me swap it out for a different question. Now, this is just a function. There's no derivative or antiderivative or integral on it, so I don't have to touch that. All that we have to do is, in order to find this guy and subtract it from this. And because those two integrals are the same, or because those two quantities are the same, whatever I get as an answer to this must be the answer to this because they're equal to each other. So we essentially now we must find the antiderivative of -2x over square root of 1 plus 4x squared dx. Now you might say this looks like an inverse trig function. Every single inverse trig function's derivative has a 1 in the numerator. So if I just had a -2, I could yank the -2 out of the antiderivative and not have to worry about it. But I have that x there. I can't just get rid of it. If you did those 100 integration questions properly, this is in fact similar to at least 3 or 4 of those. And the trick that hopefully you would have picked up there is this is a reverse chain rule problem. because you can rewrite this problem as negative 2x times, take the square root. I guess I'll show you the steps intermediate. Rewrite it as 1 plus 4x squared to the 1/2. And move it to the top. So negative 2x, 1 plus 4x squared to the negative 1/2 dx. So I take the square root, I rewrite it as 1/2 power, and then I move it to the numerator. The reason for this is the derivative of the inside of the parentheses is present on the outside of the parentheses. So this is the hallmark of a reverse chain rule problem. If the derivative of part of the problem is present in the problem, you can undo it using reverse chain rule, or it would have come from a chain rule derivative. Well, now we can guess. I'm going to guess that my g of x function is 1 plus 4x squared raised to the 1/2. You might say, well, where on earth did you get that from? Every time you apply chain rule, you bring down the power and then you subtract 1 from the power. If the power here is negative 1/2, what would I have subtracted 1 from in order to get negative 1/2? Or said another way, just add 1 to the power. So negative 1/2 plus 1 is 1/2. This is my guess. I am guessing that if I take the derivative of this guy, I'm going to get this guy using chain rule. So let's proceed with that guess. So the derivative of this guess will be 1/2 times 1 plus 4x squared raised to the negative 1/2. So I bring down the power, keep the inside the same, subtract 1 from the power, times the derivative of the inside, which is going to give me 8x. So if we simplify this, I get, let me bring it to the front, 4x, 2 would go into 8 4 times. 4x times 1 plus 4x squared raised to the negative 1/2. Is this exactly the thing we were trying to integrate? No, I'm missing a negative sign. So how do I include a negative sign? I just multiply the top by a negative 1. But if I have a negative in the derivative, it must have been there in the original problem. The other thing is, I don't want a 4 there. I want a 2 here. I have the x, that's okay. But I don't want this 4, I want this to be a 2. So how do we convert a 4 into a 2? Well, I can divide this by 2, because 4 divided by 2 is just 2. Which means if I have an over 2 in my derivative, it needed to have been in the original problem. So that's my modified guess. That, if I differentiate, will give me this guy. Let's do it, just to be sure. So if we differentiate this modified guess, I'm going to get negative 1/2 times, bring down the power, keep the inside the same, subtract 1 from the power, times the derivative of the inside. The derivative of the inside is 8x. So now I have 2 goes into 8 4 times, 2 goes into 4 twice, and then I have a negative 1 times 2, so that's negative 2x, 1 plus 4x squared to the negative 1/2, voila. So that means that my guess, this modified guess g of x function, is indeed the antiderivative of that function. So all of this analysis can be done in, all of this can be done in Scratch work. This is not something that's necessarily, you don't need to describe in great detail what you're doing here. This can be done off to the side. Or you can just put a box around it and say Scratch. I'm okay with that. But we can go back to saying this equal sign is now continuing from here. So I have this equation. The next step after this equal sign is this guy. So I'm starting still with arc cosine of 2x times x minus this integral is that. So minus a negative 1/2 times 1 plus 4x squared to the positive 1/2 plus c.